Welcome back. So here I drew two vectors. They look similar, but actually their values are a little different. And right now we don't know if they're different or not because they are given in the two different notations that we can use to express vectors. So just as a reminder, we have the component notation and we have the magnitude and direction notation. When we use the component notation, we give each vector, a vector v, as a coordinate vx, comma, vy, where vx is the horizontal component and vy is the vertical component. So in this example, our vector is defined by the coordinate 4, 2. So in this case, 4 is the horizontal component and 2 is the vertical component. On this side, we have a slightly different vector that is given in the magnitude and direction notation. So when we give the magnitude and direction, we give a magnitude v at an angle theta. So v is the magnitude, and theta, the angle, is the direction. In this example, our angle has a magnitude of 5 and a direction or an angle of 30 degrees. So let's see how we could convert, if we are given an angle in component notation, how we can find its magnitude and its direction, and if we're given a magnitude and a direction, how we can find the vertical and horizontal components. Okay, so let's start over here. What's going to help us figure this out is that vectors create a right-angled triangle when they're put in a coordinate plane. So here's when it's going to become really useful, what we learned before about trigonometry. So look at this. If I draw a vertical straight line down to the x-axis and I create a horizontal straight line parallel to the x-axis, I'm going to create a right triangle. This angle here on the right is a 90-degree angle, and the angle that we're looking for is this angle theta at the bottom that we don't know yet. So here we create basically a triangle. I'm just going to draw it here a little bit bigger. That has the angle here at the bottom that we're looking for, the right angle at the bottom right, and we know these two sides. So actually the first number on the coordinate is a 4 because it means that we counted 4 here on the x. It's the horizontal component. So the horizontal side of the triangle is going to be a 4. And the vertical side of the triangle is how much we went up in the y-axis. In this case, the vertical component of 2. So we have basically this triangle, and what we're trying to find, the magnitude of the vector, if you see here, is the hypotenuse of this triangle that we created. So what we're looking for is the hypotenuse. So the first thing we're going to need is to use the Pythagorean theorem. So hopefully you remember that the Pythagorean theorem says a squared plus b squared equals c squared. Now we're going to name these things according to our vector notation. So as I mentioned, the hypotenuse c is our magnitude, and magnitude we were going to call it v. So our c is v. So we have v squared. And here we have the a and the b. But the a and the b are just our horizontal and vertical components. So instead of a, we can put vx squared, and instead of b squared, we can put vy squared. So basically we end up vx squared plus vy squared equals v squared, where v is the magnitude and these are the components. So if we wanted to solve for v, the magnitude, we would just have to square root on the other side. So basically v is equal to the square root of vx squared plus vy squared. So this is one of our answers. This is how we're going to calculate the magnitude of the vector. So this gives us magnitude. If we were going to do it for this specific example, we have a 4 and a 2, so our v is going to be the square root of 4 squared plus 2 squared. 4 squared is 16, 2 squared is 4, so 16 plus 4, we get the square root of 20. So basically you figured out that for this vector 4, 2, the magnitude is square root of 20, and it's also the hypotenuse. So here we found a magnitude of square root of 20. Now, the direction is a little bit more confusing, but you have the tools to understand this. So we have here the the opposite side to the angle and the adjacent side to the angle. When we have opposite and adjacent, we can use the trigonometric function tangent. So we can write the following equation. The tangent of the angle theta that we're trying to find is going to be equal to opposite, which is 2, over adjacent, which is 4, right? So now how do we solve this equation? Because we have an equation, but we're looking for the angle theta, but it's inside of the tangent function. This is actually a function, so it has the parentheses around the theta. So the way that we solve this, I'm just going to tell you how it's done, is that we use a new function called inverse tan -1. And we apply it on both sides, and on the left it's going to give us theta. And on the right, we just apply it to what we have. In your calculator, you will see that you have a button that says tan. But there's also a name right above the button called tan that is tan to the -1 if you have a scientific calculator. So you click that by putting the button on top that chooses whatever name is above the button. So you press 10 and you're going to get 10 to the -1. And inside you put 2 over 4. And that is going to give you an angle. In this case, it's going to be 26.6 degrees. Right? So just the only way you can solve this is by using your calculator. There's no way to do it in your head, but you're going to get an angle of 26.6 degrees. So here we put on top, our opposite was always the vertical component. So if we want to put this as a general rule, we're going to get that the angle theta is the inverse tangent of always our vertical component, which is the opposite to the triangle, over our horizontal component, which is the adjacent to the triangle. So this is the equation that will always give us the direction of the vector. So now we have basically our two equations that lead us from here to here. If we have the horizontal and vertical components, we put them inside the Pythagorean theorem to get the magnitude, and we put them inside an inverse tan function to get the direction. But what if we have magnitude and direction, like 5 and 30? So what we're going to do is similar to this. So again, we're going to use the fact that this looks sort of like a triangle with a right angle here. And now we know one of the angles, which is 30. So basically, the triangle that we know is 30 degrees here at the bottom. The hypotenuse is 5, and it's a right triangle. And that's all we know. And what we're going to try to find is this side over here, which is our vertical component, Vy. And we also want to find this side here, which is the horizontal component, Vx. So we're also going to use trigonometric functions for this. So let's say first we wanted to calculate Vx. Vx is the adjacent side to the angle 30, and we have the hypotenuse. So which of the three trigonometric functions uses adjacent and hypotenuse? That's cosine. Cosine uses both. So we can write the equation cosine of the angle 30, now we do know the angle, is equal to adjacent Vx over the hypotenuse, which in this case is 5. So if we wanted to find Vx, we would have to solve by taking this 5 to multiply to the other side because it's dividing. So we pass the 5 to multiply and we get 5 times cosine of 30 is equal to Vx. This is something that we can put in our calculator. 5 times cosine of 30 is just a number. Actually, in this case, it is 4.33. So if you put it in your calculator, you'll see this is 4.33. And how do we do the other side? So we found already the horizontal component. And if we wanted to find the vertical component, cosine doesn't work anymore because now we have the opposite instead of the adjacent. So we have opposite and hypotenuse. Which of the three trigonometric functions uses opposite and hypotenuse? Sine. So we can do an equation with sine. So sine of 30 degrees is equal to the opposite, which in this case is Vy, over our hypotenuse, which is 5. Again, to solve for Vy, we pass the 5 to multiply, and get that Vy is 5 times sine of 30 degrees. That is also a number that in the calculator will give us 2.5. So we found that Vy was 2.5. So basically with these two numbers, we already know the coordinates or the components of this vector, 5 at a 30 degree angle. So what we found is that the Vx is 4.33, so this is 4.33, comma, and the vertical component is 2.5. 2.5. So this point here at the edge of the arrow has coordinates 4.33, comma 2.5. So we wanted to make this a general rule. What we need to do, basically what we did to calculate Vx was multiply the magnitude V, remember we call the magnitude V, times the cosine of the angle theta. And to calculate Vy, we used sine. We multiplied the magnitude V times the sine of angle theta. So these are our two equations now that give us the horizontal component and the vertical component if we know the magnitude V and the direction theta. This side over here is called resolution of vectors. Having a magnitude and a direction and finding the horizontal and vertical components is what we call resolution of vectors.